Six Sigma started from a company called company called Motorola, and Lean started from a company called Toyota. When Toyota introduced, it was named as Toyota Production System. But later on, in order to make it convenient for everybody to adopt, it was renamed. The Toyota Production System was renamed as Lean. So the birth of Lean is from Toyota. Similarly, the birth of Six Sigma is from a company called Motorola. So somewhere around 1979, a management meeting was conducted in Motorola. At the same time, the Motorola was struggling in terms of quality and feeling the competition from Japanese industries as very tough for them. And so they had a meeting, an executive meeting. And that time, the CEO of Motorola is written here, Robert Bob Galvin. He was conducting the meeting, and an executive called Bill Smith, he's an engineer, Bill Smith. And he mentioned that the quality is stinking in Motorola. And he also presented a paper in 1985, a research paper in 1985. And in that paper, he said that there is a strong correlation between the extent of repair a product underwent and its field life. So what is field life and what is extent of repair? Field life is the duration during which your product can fulfill according to the requirement. That is the field life. And this side, the extent of repair. What is extent of repair? You can produce the product in the first go also without any defect, or you can actually make a mistake in the first run, produce a lot of defects in your product, and then rectify all the defect. You call it as rework and then sell it to the market. So which is better now? Can you produce items with the defect and then do rework, rectify all the defect, and then sell it to the market? That is the best approach? Or you produce everything right at the first time and send it to the market? Which is best approach?
Be right first time.
Produce right at the first time and then send it to the market. Why it is good approach? When the products are really, you are able to produce products really right, good at the first time, same products will in the market. Is it logical? Logical or not? I produce products without any defects, and those products I market it. Those products are expected to have a good field life. If the products are failing many a times within your factory, and then you send that product into the market, what will happen? Those products may fail frequently after selling also. Am I correct or not?
Yes.
Why failures are happening frequently within the factory? Because the design is not great. I also recently purchased one, a household item, maybe a wet grinder. 1 year warranty was given. So far, within 7 months, we serviced it for 8 times. 8 times, and service engineer came, and then he replaced the product. But I am very sure the product is going to fail every month. Is it not? So the secret of quality lies in your design, in your process. You have a great design and a great process. Failure will not happen within the factory also. If the product is sold in the market, same failure will not happen in the market also. So this is the observation by Bill Smith, and he presented it. And Bob Galvin was quite impressed. Then he throw a challenge, saying to the executives that they are responsible for responsible to achieve a 10-fold improvement in a span of 5 years. That means within the next 5 years, there has to be a 10 times growth in all the KPIs. You all know KPI, right? Key Performance Indicator. Nothing but a number. Nothing but a number. That number will tell you, are you progressing towards the goal or not? If the number is telling you giving you an indication whether you are progressing towards the goal or not. The number is called KPI. If it is a number which is most important to you, but doesn't tell you whether you are progressing towards the goal or not, then the number is no more considered a KPI. The number is called a metric. A number can be a metric, and a metric can be, or a number can be a KPI. All KPI are metric, but all metrics are not KPI, right? So the Bob Galvin was interested in achieving 10 times improvement in all the KPI, and the responsibility was given to Bill Smith and Michael Harry. Bill Smith is an engineer. Michael Harry is a statistician. This engineering and statistics combination has worked very well for Motorola to overcome all the quality challenges, and it gave birth to a new approach called Six Sigma. Six Sigma is nothing but an integrated approach of engineering and statistics. We all very good, thinking, using our engineering brain, but most of the time we don't, use our statistical brain. All of us are, very good statistician by birth, and we use statistics in all our day-to-day activities. How is your performance? How is your child doing? If you ask your friend, and your friend might say, my son is doing average. So what is average? Average is statistics. So statistics we all use in the day-to-day life, but we use it, unknowingly. But if we just master some of the statistical approaches, tools, and techniques, and use it consciously in our business, you will also be able to mix up engineering and statistics very well in the business, and then produce fabulous results for your company. So the combination of engineering and statistics and engineer and statistician worked very well in Motorola, and they were able to overcome all the quality issues, and it led to the evolution of a methodology called Six Sigma methodology. Six Sigma methodology is a statistical approach, a metric-based system by which any quality issue can be resolved by fixing its root cause. And this is in 1980s, 79, Motorola was into manufacturing the pagers, mobile phones, and these kind of things. You all might be knowing pager was very famous that time, right? And the company's turnover is around $4,000 million, and manpower is huge, and they were present in more than 30 locations. And the problem is heavy competition from the Japanese companies, and the quality levels were going down. Quality levels going down, how do they understand? Lot of customer complaints, lot of warranty claims, lot of rejections, right? External as well as internal. You know what is external rejection and what is internal rejection? If your quality inspector reject the product, that is called internal rejection. If your client reject the product, that is called external rejection. Which is dangerous? External rejection or internal rejection? Which is dangerous?
External rejection.
External. You know why external rejection happened? Your internal quality inspector failed to reject the same product. Isn't it?
Yeah.
Internal quality engineers have failed to reject the product, and that's why external rejections happen. So if you take care of the internal failures, the external failure will not at all happen. You can make the external failures close to zero. You can make the external failures close to zero, and this is what is called as 3.4 DPMO. Controlling all the failures internally is called quality control. Controlling all the failures internally is called quality control. So quality control is what we call it industry 2.0. But 2.0 is not sufficient. 3.0 is required. You know what is 3.0? Making your process capable, strengthening your process not to produce internal failure. See, identifying failures internally and then controlling external failures is simply quality control. Many companies doing this job. They check the failure and then, and thereby they see to that the customers are always happy. Can you do something? Thereby you don't have to check for the internal failure, but at the same time, you should be able to effectively prevent the external failure. without even doing inspection. Can you be sure that there are no failures in the market? This thinking is called Six Sigma thinking. All of you understand the difference between quality control and Six Sigma? All of you understand the difference? Quality control, every company is doing. If customer complaints comes, immediately what do? You intensify the quality checking. Intensify, you increase the number of checking. You are trying to contain the problem. You are not trying to solve the problem. Quality controls contains the problem. It only prevents it, from moving to the further stage. But you're not solving it. But when you solve it, the beauty is you don't even have to check for it. Be rest assured. You fix the problem at the root level and be rest assured the same problem will not come again. But if you don't fix the problem, simply keep on checking and correction, that is only called quality control. We want you to work on the next level of quality control. We want you to move from industry 2.0 to industry 3.0. Only when you move from 2.0 to 3.0, you become eligible to talk about 4.0. What is 4.0? Automation, digitization. So automation, digitization are possible only if the people understand these things. What is this? Lean Six Sigma. We use the term Lean Six Sigma because it is very famous. Any effort by which you can prevent the failures, any effort by which you strengthen your process, you strengthen your design, strengthen your people are called operational excellence. So operational excellence, achieving operational excellence is 3.0, and then automation and digitization is called 4.0. Without operational excellence, trying to digitize and automate will not have any meaning, right? So see to that, you increase the capability, you bring the defect level close to zero, and then you automate, and then you digitize, right? And that can take care with the minimum of human intervention. So why Motorola did all these things in 1980? Because they wanted to become world leaders in manufacturing of communication products such as the pagers, mobile phones. In fact, they were into some other electronic manufacturing also, some televisions also they were into initially. So they wanted to become market leaders. So this is one good reason why Lean Six Sigma is required and the success story of Motorola. And another thing is ABB, power transfer plant. And they were into robotics and electrical manufacturing. And they understood an urgent need for major improvement. See, this case study is very, very important. Many a times we think that Six Sigma or any problem solving is required. Only we come across a problem. For example, if you ask some companies, sir, we have no rejection. We do not have any rejection. So Six Sigma and all not required for our company. We have 100% compliance. We never get a customer complaint in the last 5 years. So Six Sigma is not required for our company. Do you think their opinion is correct? If we don't have any complaint in the last 5 years, do you think Six Sigma is not required? Yes, someone.
But it was achieved based on Six Sigma, I think, correct? Because of this 5 years.
That could be one reason. Suppose if it is not Six Sigma, maybe some other method, they were able to maintain, zero complaint last 5 years. Do you think the company doesn't require approaches like Six Sigma? No. Every company requires this thinking. Every company deserves next level of performance. Every company deserves improvement. Everyone wants improvement, isn't it? See, there is no point simply thinking about our failures. I think one of you were speaking, right? So instead of thinking about the failures, you can think about the next level of improvement opportunities. See here, same company, ABB, they were comparing their performance with the competitors. They are not measuring their problems and failures. They are comparing their success with their competitor's success. That is next level of thinking. Look at the statement. Defect levels are 60% higher than the competitors. Defect levels are 60% higher than the competitors. It's not external failure, maybe internal failure. But internal failure means, customer doesn't know about any failure. Every product is a great product. Failures are only internal. But how they are comparing? They are comparing their defect level with the competitors. Now there are about 20 of you are undergoing the training program. Do you really want to become number one within the batch? Am I right? You want to learn more and then perform well, rank in the batch? Obviously,
Yes.
this is our general way. We from our schooling. When there are 100 students in the class, we want to secure the rank number one. Same way, if there are 100 players in the market producing the same product or similar product, every company would like to become number one. Isn't it? Every company would like to become number one. This thinking and the efforts towards fulfilling this goal is nothing but operational excellence. If your company want to perform better than the competitors, now that is the foundation for operational excellence. If you don't want to perform better than your competitors, if you think you are already doing well and you are great, then that kills the opportunities that exist for improvement. So they were comparing their defect level with the competitors and found that their defect levels are 60% higher than the competitor. If your defect levels are 60% higher than your competitor, whose profit margin will be higher? Your profit margin will be higher or your competitor's profit margin will be higher?
Competitors.
Competitor. So they will invest that profit in more research, more innovation, and then very quickly, they will outperform your product. Right now, you might think your product and their products are same. But if you allow your competitors to make more profit, they will reinvest that money and then, they will kick you out from the market. So that is that triggered the ABB to embrace Six Sigma. So the reason for ABB embracing Six Sigma is urgent need for a major improvement because their defect levels were higher than the competitors and competitors' profit were higher than you. When you allow your competitors to make more profit, you are killing your company. So this is also important. Understand. And now GE Medical System, General Electric, they were manufacturing some kind of scanners and medical equipment. And look at their statement, the quality issue. Their scanner speed and life need to be substantially improved to stand in the market. The life of the scanner is poor and then speed is also poor. Just to get a scan, your scanner requires 3 minutes, the processing time. But your competitor scanners are processing in seconds. What has been achieved in seconds, your products are doing it in minutes. Do you think more customers will come to your product? No. So again, this is similar to the second case. You are comparing your performance with your competitors and understood the necessity for a substantial improvement in the quality, right? And moreover, the failure. Why there is a problem related to the life of the scanner? An important component of the scanner is a kind of bulb, and that bulb was costing around $60,000. And see here, due to the low bulb life, 20 million bulbs were failing per shipment annually. Every 1 year, 20 million bulbs are failing and they have to replace, and cost of one bulb is $60,000. So these are all the reason why the GE adopted Six Sigma. And Six Sigma was introduced by the company Motorola. When Motorola introduced the Six Sigma had only 4 steps. What are the 4 steps? Measure, analyze, improve, control. We call them as phases. 4 phases: measure phase, analyze phase, improve phase, control. When adopted in General Electric, they converted the 4-phase methodology into 5-phase methodology. They added define in front of measure because defining the problem is more important than measuring the problem. Before measuring, you must define correctly. A well-defined problem is half done. So it is General Electric in the year 1995. They converted the MAC approach into DMAC approach, and that is what we are going to master in this black belt training program, right? So when introduced at Motorola in 1987, how many phases were there in Six Sigma methodology? There were only 4. But in 1995, after 8 years, MAC has become DMAC. And today, 2022, several years, 25 plus years, it remains same. Such a powerful methodology. I always say problem solving, if you want to call one methodology as the superior methodology than anything else in the world, it is DMAC. If you master it, it simply means you are a master of everything. You can easily follow any other methodology of problem solving, right? And these approaches gave a lot of returns and savings to the companies. For example, Motorola saved $2.2 billion every year in manufacturing projects initiated from manufacturing domain. The savings are $2.2 billion, not a small money, right? And in non-manufacturing, they saved $1 billion annually. $1 billion annually in non-manufacturing. This is a clear evidence right from the inception. Six Sigma is applied not only in manufacturing, but also in non-manufacturing. Some of you might be working in service industry. You might be into coding and software development, or some kind of service. Hospital is a service industry. Education is a service industry, and Six Sigma can be applied everywhere. All that required is every learning is a philosophy. Every lesson is a philosophy. It can be customized and applied in all domains. The tools and techniques, your focus should be on solving your problem, not learning others' problem. No two problems can be exactly same in the world. The kind of problem I face in my personal life is never going to be same for any one of you. Your problems are going to be completely new. Only you can better understand, only you can solve. So what I'm trying to say here is, whatever you are learned is a philosophy. Whatever you are learning from the program is a tool, is a technique. You must be a master of customizing the tool and use it to get your problem solved, right? And then you are called a black belt. And 68% reduction in the defect levels achieved by ABB, 30% reduction in the production cost, and $898 million savings each year. And for General Electric, the success story goes like this. They spent $500 million and got back $2 billion within 1 year and $12 billion in the next 5 years. So this is the motivation for why many companies are running towards Six Sigma. Why every company want to embrace Six Sigma. If they know all these things, I'm sure they will immediately support the Six Sigma initiative. The companies practicing Six Sigma, they quickly become brand leaders. Or you identify any brand leader and go inside and check up, they will be practicing Six Sigma. It is vice versa. So what is Six Sigma? Six Sigma is an operational excellence model, an aggressive campaign to boost profitability, an aggressive campaign to increase the market share, an aggressive campaign to increase the customer satisfaction using quality as the strategic business focus. Right? Companies should have a culture to support continuous improvement. Everyone should be thorough with the fundamentals of quality principles. Right? Quality comes by meeting your customer's requirement. Very simple. If this is not understood, if you don't know who are your customer, then you have poorly understood the quality, right? So quality is the strategic business focus, not money. Money is a byproduct. Take care of the process, your results will be taken care. Take care of the quality, your profits and revenue will be taken care. So this is the kind of strategy companies will have if they come forward to adopt Six Sigma. If quality is not the strategic focus, quick money is the focus, then Six Sigma may not work effectively. Hope all of you understand, right? So Six Sigma aims at progressively, aggressively, and continually adding value by reducing variability. Here the term variability is a statistical term. You must thoroughly understand what is variability. I produce 1 million product. Do you think all 1 million products are exactly same? No. There will be some differences. There will be variability. As long as that variability is minimum, customer can't see it as a problem, isn't it? If then if that means variation is the root of all the problems, quality issues. You reduce the variation, problem is addressed at the root level. You produce 1 million product, all 1 million products are accepted. You produce 10 lakh products, all 10 lakh products are accepted by the customer, right? And the benefit is customer satisfaction, cost reduction, and not only that, legal compliance. Automatically, you will be able to comply with all kind of your quality management system. You don't have to worry about all their classes because they're all system level approach. But Six Sigma is process level approach. If processes forms the part of the system. If processes are great, system will obviously be great. If you design a great system, it doesn't mean results can come from it. Still the processes can be wrong. But Six Sigma is a process level approach. Six Sigma is a product characteristics level approach. A product can have 100 characteristics. With respect to each characteristics, you can measure the sigma level. So it's an endless job. Please understand, ladies and gentlemen, here, please understand. It is an endless job you have got to achieve the best in class quality. So improvement is a never ending journey. Variation is cannot be eliminated. You just cannot eliminate. If you can eliminate variation, the same moment you will lose your job also. So variation is unavoidable, and reducing variation is your primary job. You will come to know and you will appreciate my statement very well only if you master some of the basic statistical concepts. So you are given different designation, but primarily your job, your main job in your workplace is reducing variation. Hope so far is clear to all of you. So what is Six Sigma? Six Sigma is a management philosophy to meet using the variations. Understand the connection. You meet the business objectives by reducing variation. How many of you are able to appreciate the statement? All of you are able to appreciate this. You can meet your business objectives by reducing variation. Is it correct statement?
Yes.
Right. I want to improve my market share, reduce variation. I want to improve my share price, reduce variation. I want to delight my customer, reduce variation. I want to maximize my profit, reduce variation. The lowest statement, right, or the final statement for all the problem is reduce variation. That's all. The root of the problem is variation. So that is why it's Six Sigma is considered a management philosophy to meet the business objectives by reducing the variations. All right. A disciplined data-driven methodology for decision making and process improvement. Six Sigma is nothing but Six Sigma demands this. To improve the process performance, we need to decrease the variation and the defects. You decrease the variation, automatically defect will decrease. See here, there are two processes. One process like this, you are seeing a kind of bell shape, and another process. This is also a bell. Now tell me, this is left side, there is a process, right side, there is a process. And tell me which process is wider and which process is narrower. Is the left side is wider or the right side is wider?
2 sigma is wider.
Left side is wider.
Left side is wider. When you say wider, it means the spread is more. It means the spread is more. If the spread is more, what does it mean?
Variation is more.
Variation is more. Suppose I conduct a black belt training program and the average score of the black belt students is 80%. Average score is 80. Anybody joins, he is likely to get 80 mark. But when the spread is more, can you guarantee results to your students who are joining? No. Average is 80. Some people might score above 80. They can go close to 100. But some people can come below 60 also. So there is a risk involved. So when the spread is increasing, what does it mean? Your risk is increasing. So in any business, in any process, what is required is a lower spread. So out of the two processes, what you are seeing, which is more beneficial to your business? the right side one. Am I right? Yes or no?
Yes.
For the simple reason that the spread is low. When you are looking at the spread, I also advise all of you to look at the center also. Look at the center. Suppose if the class average is 80 on the left side, class average is 80 on the right side, you can compare and take a decision and you can conclude that the right side process is great. The right side is Vision Excellence and left side is all other companies. Please proceed with the Vision Excellence for your black belt enrollment. How are you able to take a strong decision? Because the average mark is same at both sides. Here also 80 mark. They are also giving 80 mark. Here also giving 80 mark. But why this is better? It comes with a lower spread. The results are for sure it is going to happen. What you expect will happen. So there are two things you need to look at. One is the central value. Other thing is the spread. And spread should be lower and the central value should be your target. Right? So customer target needs to be met at the same time with the minimum variation. So average should be on the target and spread should be lowest. So if you do that, the result will be, there will be less wastage and less rework and reduced cost, greater predictability. You can predict what is going to happen. You enrolled in the program and everything is guaranteed. That's all. There are many other programs where you enroll, you get the mark, but still they struggle a lot in the career. Why they join the program? Only for the career growth, but they struggle there. So that is because the spread is too much. There is no, quality is not the strategic focus. Maybe certificate is the focus. So you can easily understand the capability of the organization, the capability of the process by looking at the distribution. This is called visualization of the process data. When I visualize the process data, and most of the process will look like bell shape only, and that is why we call it normal distribution. Normally all process will follow normal distribution only. Normally all process will follow normal distribution only. You can master the other distribution also. If you ask Dr. RK, will teach you all possible distribution, variable distribution, Poisson distribution, binomial distribution, gamma distribution. He can teach everything that you want to learn. But majority of the process will follow normal distribution only. So by mastering the normal distribution, you can solve 90% of the problem. Even the remaining 10% of the problem, you can solve by learning a theorem called central limit theorem. So both will be taught. Listen very carefully and then master all those things. So the result is happier customer. When your process graph is appearing like this, it simply means you are going to be first time right always. You are not only good with your average, you are also good with your spread of the process. Is that clear to all of you, this particular slide? Shall we move on?
Yes, sir.
Yes.
And feel free to ask your doubts if you have, if you are not able to understand anything. And since you have not asked, I want to ask a question here because your turn is now over. It is my turn. What is this LSL and USL? Can some of you tell me? Something written here, LSL and USL.
Specification limit, lower and upper specification
limit.
Very good. Lower specification limit and upper specification limit. Who will provide you the information about lower specification limit and upper specification limit?
Customers.
Wow, beautiful. Customer will provide the upper and lower specification limit. For example, all of you, can you give some specification as far as the training program is concerned? What are your specification? Right? Let's say the test score. There are so many requirements from the training program, right? Only for discussion sake, I use test score. If you write the black belt exam, what is your targeted score you want to see in your scorecard? Your target is here. Tell me. What is your target?
More than 95.
Then 95. Okay. 90. Let us take it 90. 90. You want to see 90 here in the center. Now give me the upper specification limit and lower specification limit. What is tolerable? If you score 90 and above, definitely everything will please you. So there is no specification on the right side. Am I correct? You can go up to maximum also. But what is your tolerable limit on the left side?
60.
-5.
Okay, so Suresh wants more perfection and Vikram is tolerable up to 60. So always customer will always have a target, will also have the tolerance range. You call it tolerance, plus or minus. Target plus or minus tolerance will give you the specification limit. Target plus the tolerance on the right side gives you upper specification limit. Target minus tolerance on the left side gives you lower specification limit. If you run your process to produce output lying inside the specification limit, your process is capable. Am I right? You run a process. Process means it converts input into output. Am I right?
Yes, sir.
All the output, if you get it inside the specification limit, you are running your business very well. Everything you produce are accepted by the customer. You can raise the bill. So this is what is called capability. You produce so many products, you offer so many services, but all of them are acceptable. This is called capability. How much capable you are, we measure in terms of sigma level. Is that your capability is 1 sigma capability, or 2 sigma capability, or 3 sigma capability, or 6 sigma capability? And that answers how good your business is. And you will be understanding what is this capability and sigma level, probably in a session during the measure phase. So how 6 sigma works? See, if you cannot express your problem in numbers, you do not know much about it. You might have a lot of quality problems in your company, but you should be good enough to express your quality problem in the form of numbers. If you lag in terms of skill to express your problem in the form of number, you will also lag in terms of solving the problem, right? So first requirement is any problem in any organization with respect to any product or any service should be converted into a number problem. The moment you convert that into a number problem, then you can play the number game. The number game is nothing but statistics. And if you know the tools and techniques, you can play the game very well. You can play the game very well and then win the game in your favor. So any problem, any real-time problem, you must express in terms of numbers. If you don't express, then you don't know about it. If you don't know about it, then you can't control it. If you can't control it, then you should be at the mercy of God. Just pray God to get all your quality problems resolved. Aida Puja and Thai Puja and everything's are coming, You can worship God on the day and then expect the problem get resolved. But if you want to take the responsibility and solve by yourself, please convert your problem into a number problem, which is a statistical problem. And for the statistical problem, there is a solution, ready-made solution given by Frederick Goss. Who is Frederick Goss? He is a famous German mathematician born in the year 1777. He introduced a theory called theory of normal distribution. According to the theory of normal distribution, you can find a solution to any problem. The solution secret lies with average and standard deviation. In the previous graph, we talked about center. The center is nothing but average. We want this center to be the customer target. Your average should overlap with the customer target. And the spread, you all told me that spread should be less. If the spread is less, standard deviation will be less. Take care of the average, take care of the standard deviation. That is called the statistical solution. I straight away break the secret. Average should be on the target. Standard deviation should be as low as possible. Standard deviation is generally denoted by the Greek letter or Greek symbol sigma. Greek symbol sigma. Sigma should be low, average should be on the target. If you make it happen, your problem is solved. You will have the solution. This is called Six Sigma methodology. This is what is recommended by Bill Smith, Michael Harry, and Jack Welch, from Motorola and General Electric. Do you understand the logic? Real-time problem, convert it to statistical problem. For statistical problem, get the statistical solution. How will you get the statistical solution? By providing the practical solution. All of you understand?
Yes.
Yes, sir.
Yes, sir. Yes.
Can you now tell me what is statistical problem? Let us say you have a big problem in your company. The task is given to you. How will you communicate statistically?
Bring it into values. Sir. For example, so voice of customer is the problem. That is, the production rejection is very high. It is just a statement. It is not giving any values. Where we have to measure and get the values. What is our target and where we are now, and so everything convert into values so that we can fix that to achieve our goal.
Beautiful. Customer says, no, products are not good. But why it is not good? The dimension is not good. Dimension is measurable. Dimension is a number. And what is the requirement? Dimension should be 100. So your target is 100. So always, every time you collect the data, average should be on the target. Simple. Get your average. Anytime you go and take a sample of products, measure the dimension, the average of the dimensions in your sample unit should be equal to the targeted value. If you take 5 samples, do you think all 5 samples will have the exactly same dimension? You already said no. But if there is a difference, that will lead to spread in the data. The spread can be measured in terms of standard deviation. And as long as the standard deviation is low, the average, you can rely on the average. The standard deviation is high, still you rely on the average, sometimes you will be in trouble. So in order to trust the average, deviation should be low. Clear? So this is called a statistical solution. And operational excellence is a monumental task. What is monumental task? Everyone's involvement is critical. If you have got a team, project team of 5 people going to address a problem, all 5 people should involve in the project, should be equipped properly,